Hi, everyone. Welcome back. Today we are in grade 6. This is Unit 7, Lesson 10. Today's lesson wants us to compare strategies for solving percent problems. Now, you've heard me say many times before we need multiple strategies in all areas of our life in order to solve different problems. No sports team, as you've heard me say many times, no sports team goes into a big game with one play in mind. Just doesn't happen because if that play doesn't work for whatever reason, if it's not a good setup, if it's an offensive play and they need a defensive play, we need lots of plays. So we've been working on making a math playbook of all of the different plays that we could use. So it's important to be exposed to lots of different plays and practice lots of different plays so that in different problem solving situations, you've got a lot of ideas to draw on and you've got a lot of things that you can use to solve the problem. So today we're talking about percent strategies. The first one that we are listing and thinking about is to draw a picture or draw a double number line, which is a picture, but it's a special kind of a picture. Draw a double number line and then use reasoning to solve it. Now, your book has two big scenarios that it wants you to think about doing all of these plays on two different problems. But since they're already laid out, I'm going to actually choose some of the other problems and I'm going to show you all four strategies. All four strategies will work on all of the problems. So if you get stuck later on, go back and watch that part of that strategy and you'll figure it out. So the first one, drawing a picture, we're going to use the problem number 7. What is 40% of 70? And we're going to specifically choose the draw picture. So we're going to draw the double number line. So there's our double number line. Now we need to figure out how we can set it up. What can we put on our double number line? What is 40%? So we're trying to figure out what 40% is. What is 40% of 70? Out of 70, what's 40% of that? So that tells us that 70 is the whole thing. So we know this is going to be 0, this is going to be 70. That's the whole thing. That's an important distinction. Some of them are going to ask you, the number they're going to give you is going to be the part, the portion of what you're talking about. This one, 70, is the whole thing. So you have to read carefully and think, what is 40% of 70? Out of 70, how much is 40%? So that 70 is the whole thing. If it's the whole thing, what else are we going to call it? Well, I hope you know we're going to call it 100%. So 70 is 100%. Okay, well, let's cut up 100% into the different percents. We see 40% is on the tens. It's a multiple of 10. So let's start there. Let's start by cutting it into, there's the 50. There's 10, 20, 30, 40. Now you can see that my number line isn't exactly perfect. It doesn't have to be, it's just to represent. But if it really bothers you, you can fix it. But that's not the important part. The important part is just representing it so we can get our thinking going. There's 60, 70, 80, 90, 100. So we got our number line. There's the percent. And this is the actual number. Now, how are we going to divide up our 70? Well, we have these divided into 10 groups. So here's 50%. We know that's already half. 50% is a great place to start because we know it's half. So you might already know what half of 70 is. I actually do. You might too. If you don't, no worries. I do. So I'm going to go ahead and write it in. But if you don't, no worries, because we're going to divide it into the same chunks that we do our percent. So we divided that into tens, groups of tens. So we're going to cut this into 10 pieces. So if we divide 70 into 10 pieces, here's the 10 pieces, 1, 2, 3, 4, 5, 6, etc. If we're going to divide 70 into 10 pieces, what is 70 divided by 10? Well, I hope you know that's 7. So you know each of these is going to be worth 7. So let's still divide it into 10, just like we did down below. In fact, we could even kind of connect those if that's helpful for us. Now we divide that into 10. 70 divided into 10 parts, we said was 7. So this is 7, 14, 21, 28. Put the 35 maybe in the wrong spot there. 35, 42, 49, etc., etc. So we can even leave part of it blank if we want because we're looking for the 40%. The question says, what is 40% of 70? So we've already got the 40%. Look at that. So what is the number that's 40% of 70? 28. Now let's think logically about that. That's what use reasoning means. Use reasoning means think logically. Now, half is 50%. Half is 35. 40% is a little less. Does 28 make sense for it to be that answer? It does. If we had accidentally gotten the number 49, then we'd say, well, half is 50, so less than that is, wait a minute, 35 is 50. That wouldn't make sense, would it? So pause after you draw your picture and kind of reason and think logically. Make sure you pause and say, does that answer make sense? And the answer is, yeah, it does. It makes a lot of sense. Let's go on to the next strategy. All right, the next strategy we're going to look at is make a table or a factor puzzle. Remember, factor puzzles are just small tables. Make a table or a factor puzzle and make sure to label it. Labeling is going to be really important because that's the way you're going to know where to put things. So the problem that we're working on is number 8. 40% of what number is 70? So I'm going to start out making my small table or my factor puzzle. Now, I'm going to actually label before I start putting the numbers in, because that way I know for sure that I have the numbers in the right spot. So I'm going to label the whole thing on the bottom. So that row is going to be things that are the whole thing. And our book uses the word portion. I'm going to use the word part, but know that when you see our book using portion is just another word for part. Portion just means the amount that you're talking about, but it's not the whole thing. So we've got the whole thing is the row on the bottom, the part is the row on the top. Now we need to figure out, one of them is going to be the number, and one of them is going to be the percent. Now it doesn't matter which one you put on which. So I'm going to put, this is the number, and this is the percent. Now that we have it labeled, we have to figure out where to put the numbers that are in our problem. 40% of some number is 70. So I'm going to start out with the easiest one. The easiest one is the whole thing is always 100%. So the whole thing, where whole and percent, where they cross, the whole thing is always 100%. So that's the easiest one. Now remember, you might have flipped these labels around. That's okay. You might have even flipped these labels around. That's okay. You just have to make sure that where you put the number makes sense with where you put the labels. And that's why I labeled first. So I've got the whole percent is 100. So we're good with that. Now, we also have 40% in our problem. Where's the only other box that 40% could go? It's got to go in the percent category. And 40% is just a part. It's not the whole thing. So it's got to go in the percent part. So we got 40%. So there's 40%. That's a part. There's 100%. That's the whole. We're off and going. We're doing great. Now, we need to figure out something else. Part of the problem. 40% of what number is 70? We got to figure out, we know 70 has to go somewhere, but is it a part or is it the whole? We got to read carefully to figure that out. 40% of something is 70. 40% is 70. That tells you that 40%, the 70, that's the part. We say 40% of something is 70. So 70 is the part. So it's the number. It's got to go in the number section, and it's the part. Do you recognize this now? Now we're set. Now we've got a factor puzzle that we can solve using a wide variety of strategies, but this is the box that we're trying to solve. So now you can say, okay, well, what's a common factor between 70 and 40? 10. Let's say that's in the 10 row. Now, 10 times something gives me 70. 7. It's got to be in the 7 column. 10 times something gives me 40. 4. It's got to be in the 4 column. 4 times something gives me 100. 25. What's 25 times 7? Well, I know that's 175. Now let's see if that makes sense. The whole is 175. The part is 70. The whole is 100. The part is 40. Since 100 is bigger than 40, the whole number that we found has to be bigger than the part. Is that true? It is true. Now, 40 is pretty close to 50, so it's almost double. So let's say this is the bottom row. This number is about double and a little more than the top row. Is that also true down here? Is this about double and a little more than this one? It is. So that helps us also say, does that make sense? Does what the answer that we found using that system, does it make sense? And the answer is, it does. It does make sense. So that's how to use a table or a factor puzzle, and specifically, and that's why I put it right in the title of the strategy, labeling it helps us organize our thoughts. So that's really, really important. And then how you solve the factor puzzle, you can do that any way you want. But drawing it out and labeling it and putting it in the correct boxes helps you organize it. That's a great strategy. Let's go on to the next one. All right. Now, I'm going to call this the of and is strategy, and it uses inverse separations. This is a really powerful strategy that's based on math vocabulary, and I used this strategy all through middle school and high school, and it really served me very, very well. If you know what of means in math, and if you know what is means in math, then you're in great shape taking apart this and turning it into an equation. 30%, whoops, I missed the last little circle there. 30% of what number is 120? So we got to know what of and is means. What does of and is mean? What do they mean? Of means times, as in groups of. Of equals times or multiply. Whenever you see of, that's what it means. It means multiply. And you remember that because times means, you hear it right in there. Times means groups of. So, of means multiply. Is. What does is mean? Equals. If I say 5 plus 2 is 7, I mean equals. So by using of to mean multiplication and is equals, we can write a number sentence right out of the problem. And that helps us get started solving it. And we're going to use inverse operations to solve it. 30%. Okay, it's just right in there. We're just going to write it. 30% of, there it is, means multiply. 30% times. 30% of what number? How are we going to write what number? Well, that's the mystery, isn't it? You could write a box, you could write a question mark. Hopefully you know I can choose a variable. Doesn't matter what variable it is, but you could choose a letter because a letter is just a number we don't yet know. So I'm going to choose X. 30% times X. 30% of what number is? Is means equals 120. It's right there. Look at that. Just using the words and what they mean in math specifically, we were able to construct an equation that we can solve. Now, 30%, remember, we don't know what to do with percents just as they are. We have to change them into either decimals or fractions. Doesn't matter, whichever one you like best. So you could say 30% is the decimal 30 hundredths. Then times X. So 30 hundredths X equals 120. You could change the 30% into a fraction. 30 hundredths, again, times X, times a mystery number, equals 120. Now, those are both good ways. Either one doesn't matter at all, whichever one you like to work with best. But now we have to get X all by itself. We got to isolate the variable. We want X on one side all by itself. So if we're taking 30 hundredths times X, we don't want to take 30 hundredths times X. So we're going to divide by 30 hundredths to get rid of that. Now when we divide by 30 hundredths, we got to do it on both sides too. So we're going to change this to be X equals 120 divided by 30 hundredths because we divided it over here to get rid of it. We don't want to multiply, we want to divide. And then we have to do it to the other side. Now, what is 120 divided by 30 hundredths? Well, if you're not sure or feel like, oh man, this is a lot of work, this might be a good time to use a calculator. The reason I say that is they're not wanting us to learn how to divide by decimals. They're wanting us to learn how to work with percentages. So you can type it into a calculator. So there it is. I don't know if you can, oh, that's really hard to see. Oh, there we go. 120. Oh, there we go. 120 divided by 0.30. That's how I typed it in. 120 divided by 0 and then the decimal point. It's right down there. 0.30. And then equals, man, that doesn't show up very well. There we go. 400. Okay, so either way, no matter how you set these problems up, you both need to divide by whatever is being multiplied by X. That's the idea of inverse operations. And they both give us that X equals 100, now, or 400. Now, before we're done, we're going to go and put that back into our number that we read, our problem, and see if that makes sense. Because if as we read it, that answer doesn't make sense, we know we might have made a mistake. And then we just go back and find the mistake and fix it. 30% of 400 is 120. Well, it's only 30%, so it's much less than the whole thing. So a third, roughly, of 400 is 120. Yeah, that's right. That makes sense. A very small percentage of 400 is 120. That's it. That's working great. Let's go on to the next strategy. All right, our last strategy for today is setting a proportion, which is using equivalent ratios. Now, setting a proportion is something that you probably heard me say I taught in 8th grade math all the time. We used to work on proportions day after day after day. And so if you can figure it out now, you'll be a genius, you'll be a math genius. So here's the question. What is 30%, incidentally, this is number 10. What is 30% of 120? So we're looking for some number that equals 30% of the number 120. Well, if we're setting a proportion, we're going to set up two kind of ratios that look like fractions, and we're going to set them equal to each other. Now, one of them is going to be 100%. So I'm just going to start with that one because it's easy for me to get started. I know there's going to be 100% here somewhere because in order to tell the percent, we need to have it percent out of 100. So we know there's going to be 100% somewhere. And I like to put it on the bottom because that just makes more sense to me. Now, okay, so then we also have what is 30%. So here's 100%. What is 30%? And out of 120. All right. Now, when you go back, you read, I have 30%. So you say, okay, well, I know I have 30%. I can put it in somewhere, but how do I know where to put it in? Well, the answer is there are a lot of choices, and it comes back to the same strategy that we used and employed when we were doing the table and the factor puzzle. You have to decide where you're going to label things. Watch this. You could label this row as the percent row. If this is the percent row, you've got 100%, and then 30% would go right here because it's in the percent row. But check this out. You could label the percent column. And then you've got 100 here and 30 there. That's the cool thing about proportions and equivalent ratios, and also about factor puzzles, is you can change the labels, but you have to put the information in according to what your label is. So if you are more comfortable with 30% and 100%, then we can figure out what to do here. If you are more comfortable saying, no, I don't want to do it that way. I want to put percent going side to side. So this is 100%, and this is 30%. Well, then do that. Works either way. So we've got the percent. 100%, 30%. What is 30%? We know we're looking for the part. What is 30%? Well, if we're doing the what is 30%, should that go with the 100 or should it go with the 30? It should go with the 30. What is 30%? That's a mystery number. What is? We don't know. We're looking for it. What is 30% of 120? Out of 120. So the part, this is actually the 120 is 100%. We want to know what 30% is. Do you see how we set that up? We thought through, we reread, and then we started by putting our labels in to help us match it up. Now, after we do this, we're going to say, then cross multiply. $100x, 100 times x is 100x, 120 times 30, I just know my 12 facts of my zero trick. So 12 times 3 is 36. I got 1, 2, 1, 2. I don't want 100 groups of x. I only want one group. I want to isolate the variable. I want one x. So I'm going to divide by 100, divide by 100. X equals 36. All right, let's see if that makes sense. First of all, I went over and I changed that label from the part. We started writing the part we were looking for. It's actually just the number that is that part. The numbers, that's the whole, and the number that's the part. So I changed that label to be the number and the percent. Now, Look at this. X is 36. Let's see if that makes sense with what we've got. Because this is always the last step, is say, did we make a mistake somewhere? Or does that answer make sense? X equals 36. We said the number we're starting with is 120. That's the whole thing. We want 30% of it. 30% is about a third of it. Is 36 about a third of 120? The answer is yes. So we know we got it right. So there are 4 different strategies that you can use. Now this video was kind of long because it takes a long time to explain all 4 strategies, but it really is important that you're kind of thinking and practicing them. So I encourage you to choose different strategies for different questions and try it out and figure out which ones are easier for you, which ones are harder for you, and figure out how they work in different situations so that you then are a master of all these plays and you can choose a play. You're not just stuck with the only one you know. You can choose a play that's going to work best for that problem-solving situation. See you next time.